Currently, I'm working at Intel in Portland. So this has been a collaborative work with Bodong, who's also part of our speakers in this group today. So the topic today I'm going to talk about is to understanding the lifespan and spread of ideas. And we are doing that through to the epidemiological modeling, and we're using participation in Twitter as our data set uh, to know more about this research topic. So let me give you a background about what we call as a lifespan of an idea, what we term as it as a framework. So it's based upon three different things here. One is connectivism, the theory, and for example, very quickly, you have to explain. So for right now, what's happening right all over the world, we are going for online learning, but given an instance of a student trying to learn a certain topic has in class has learned something in class and then comes out and then tries to find different sources to learn about that, and then engages in interactions by making connections not just with people to learn but also with entities. And then he might go forward and then try to I mean, he comes up with questions and goes to discussion boards, and that's where the chain bound process of this connections he makes, and that's how the knowledge is being spread all over. So that that's connectivism, and moving to the next theory that we are trying to incorporate here is knowledge building, which is wherein the basis is ideas and generation of ideas, and then ideas also, they believe that the ideas go through iterations and modifications, and then some ideas might be trashed and some might be reworked. So it's that continuous work of making, and it's a collective work. Which involves again people and entities like softwares or materials or whatever. And then moving on, so to attach both of them into a learning perspective, and we are using epidemiology here. Epidemiology is nothing but the science of spread of diseases, and how do they gauge and how do they interact and among the people, and how it is being spread. So the idea what we are proposing here is we can gauge the spread of these ideas through the lens of epidemiology, because in both the cases, when of the both theories, or what we are the one of some both the theories, the learning is is a network forming process, and in this network forming process, they are influencing each other, or we should say they're infecting each other with the ideas. So a study of this transmission dynamic from the origin until its survival and also the evolution, we're calling that as their framework called as lifespan of an idea. So moving forward, so ideas is a knowledge creation process, and then learning is a network forming process. In between, whatever the connections they're forming, that's an epidemic process. And so and this epidemic process has its own dynamics, and then thus if we analyzing those dynamics would give us give us an estimation of how this idea is being moving around. For example, so in the last year like I had a chance to talk about this at a workshop, wherein I took an example of online forum about their data science, and I was trying to see which language, I mean computer programming language, had more number of questions, and it turned out that Python versus R had gone up, so sometimes it was Python and sometimes it was R, depending on the year. So out of 4 years it was a fluctuating thing, but by the end of it, those two languages stood out to be the most popular ones, and that I should say the most popular ideas among the data science group. Uh, that and modeling that uh, basically is the goal of lifespan of an idea. But here today, we're going to talk mostly through the lens of participation as the first step towards this framework. But a little background about the work, about is there anything that already present in literature? Yes. So the idea, the whole idea of mathematical application or using epidemiological modeling on spread of ideas actually dates back to 1960s, wherein they're trying to analyze how certain topics about cell biology have been trending from 1940s and 1920s until 1960s. But cutting that and moving forward back in 2006, that's when some of the interesting work has happened. Where you can see is epidemiological modeling of a research topic called Feynman diagrams, and then they came up with an modification of the existing epidemiological models by incorporating certain groups that are specific to the education research. And then it moved on to the to picking a single word called kinesin. It's again a biology term, and then they tried to see how did it spread across different disciplines of science, and that was the research work. And then moving forward, there's one more work that talks about the modeling of news and rumors on Twitter, and they took up the general news topics that that they came across, or the news headlines, and then they saw how people are interacting among themselves, and then sustaining that news item apart from a from a TV channel, but actually into the real social in the world, and then socially interacting and sustaining it over time. So that's the background of it. And then moving forward, so here I'm going to pick one particular epidemic model. There are multiple models based on the situations that you would like to address. Here we're calling as SIR. Stands for susceptibles, I stands for infective, and R stands for remote. This is known to be the basic epidemiological model, where the susceptible group is vulnerable, or the people who are vulnerable to acquiring an infection, and infectives are class are people who have acquired by interacting with other individuals or directly from the source. And removed is our recovered people who have attained immunity. And the assumption here for this work that we are taking is that there are no births or deaths and growth of population. The reason being, we are in an online data set that we are taking, and we are taking data sets of 3 conferences and 1 long-term chat group, and we have a set time period. So that's the reason we are considering only all those people during that set time period. And and in reality, for an idea, there is nothing called as death. It's only or removed because it gets reiterated at some point of the time. So that's those are the assumptions we are making for this epidemic model. And some other things that I will be talking about in the next slides is about rate parameters, or rate of infection, which is alpha, and beta is rate of removal. You would be seeing that in the following slides. And then uh, the first set of differential equations that you see here are the differential equations that define this model, and the next set of equations that you're seeing here are basically solutions to this model, and this would be the basis on which I'm going to analyze the data sets. And another piece of information that I would be considering is the reproductive number. So anything R naught greater than 1 causes the disease increase shows that there's an increase in the occurrence of disease, or the sustenance of the idea to. And then R naught less than 1 is decrease in the disease occurrence from the epidemiology point of view. But for us, it is basically the idea is not spreading enough, or it has already reached saturation. So the research question that I would be talking about here is, how does an idea come to exist, spread, and develop in a communal socio-technical space, and specifically through the lens of social participation? So ideas that are flow. So we've taken a digital network social space here, and then we are defining defining what we call as ideas, and we're trying to understand the contagious nature. So all the previous studies that have been made on this spread of ideas called ideas to be contagious, and then they can be transmitted from one person to the another person, either by thought or by interaction or through the published papers. So there are multiple methods, and in this case, we are considering Twitter and then engagement patterns on Twitter. So here, applying the lifespan of idea framework to model the social participation on Twitter. So let's define the SIR model for the Twitter space for all our audience here. So the data source is nothing but the Twitter, as I already mentioned, and my susceptible group, or the group of people who can probably be influenced, are are the people who are following or followers of the particular person. For example, here I'm taking the example of George Siemens, and then we can see there are about he's following about 1,700 people, and then there are about 23,000 people that are following him. So all these people fall in a susceptible group. And for example, if we take one of his posts to be infective, and then see how many people are commenting or retweeting it or liking it, those people fall into the infective group. But one of his earlier tweets where he had one of his earlier tweets would become removed because not every tweet sustains for a long time. The effectiveness of a tweet is determined by the content it has. So here we're just going to consider it as consider that a tweet after a few hours or a day, which I will define clearly when I come to the data set. But for here for this example, if you say March 11th, and this was probably March 13th or so. So during this time, this particular tweet has lost his infectiveness, and then he has another tweet here, which is the new infected tweet, and that's the new idea. So all these people who have interacted here fall into the removed group, and all the people who are interacting here will eventually fall into the removed group after this tweet has lost its effectiveness. So that's defining our SI and R. And the reason I have it here as this particular image is people keep falling in and falling out of each group, especially on an online space. So the data sets that and pre-processing. So as I said, mentioned, the data sets are from Twitter. So specifically, we've taken three conferences. That is two of our LAC conferences from 2017, 2019, and then one conference called International Literary Association of 2017. And then there is one long-term chat space called Texas EduChat, and that's basically a chat space where teachers and and people from the education background and students as well as their parents can interact with each other on various topics related to education. For example, one of them could be the teachers interacting with other teachers on what are the new methods of online teaching that they are trying to use, and that would initiate a discussion session. So here I've collected the data sets using two different methods. One is called tags, Twitter archiving Google spreadsheets, and then the other one is basically scraping the Twitter variables uh, using a Python program. So in any case, anyway, for all these data sets, the things that I'm interested or features that I'm interested in are user ID, or author names, text of the tweet, timestamps, and hashtags. Mostly, I'm focused on the usage of hashtags because here I'm going to define that or like that's basically the mode of participation, that they tweet something and then they put a hashtag LAC 2019. That's how we know that they have participated something related to LAC 2019. Uh, Sorry. Um, so moving forward, the adaptation to the Twitter data. So susceptible class are all other individuals on the Twitter group who would have feature authors, and infective class are people who are currently posting or current authors, and then remote class are people who after they have lost their infectiveness. And the tweets from the conferences, we assume that they lose their influence after one day. And for the chat space, I've assumed that they lose infectivity after end of 1 month. And the methods, going to the methods, so we put the people into this different buckets, and then basically have a number count on of each day. So the way here it works, so I've shown you the Euler's solutions. So if you take the left hand side and right hand side and then divide them apart, so all your left hand side equation left hand side part of your equations become your SIR measured, and your right hand side becomes SIR estimated. The reason being, on your right hand side you have so what you call as rate parameters, and these rate parameters define the propagation of the disease, or in fact here the propagation of the idea. And then this and that rate parameter can be used to determine how long beyond this particular days, the time frame that we have set, we can gauge and see how long is it going to sustain, survive, or maybe saturate after that time period. So first thing that we are taking is all the individuals on day zero, which is basically one day before the conference, are we take them as our initial set of infectives, and every day the new set of every day we count the number of tweets that are there from each unique individuals, and that forms the total number of tweets that are for that day, and that forms the infective group. And susceptible group are people of the complete set of people that have interacted along in those in all those days of the conferences. The complete group is called the susceptible group. And then removed would be basically, as I said, from the previous day. So if you tweeted today, tomorrow that would be removed. And the idea here is to minimize the difference between SIR measured and SIR estimated. That's how we calculate our best fit parameter for the rate parameters. And that's how we calculate all the optimal rate parameters. So so explaining it through the through results. So if you see lack, so the graphs that you see here are basically the points are the number of infectives on each day of the conference. And just for the sake of a completeness of a curve, I have taken one day before the conference start of the conference and one day after the end of the conference. So whatever you're seeing as the day 1 and day 6 for lack, or day 1 and day 5 for ILA conference, are basically the day before and day after the conference. And for the Texas Edu Chat, it's basically 1 month before and 1 month later. And here you can see that the different engagement patterns, that you can see the number of people that are interacting on day 2 and day 4 has strikingly similar coincidence, or it's similar feature with lag on day 2 and day 4 and of 2019. And again, and when you look at ILA conference, especially on day 3, they had the high peak, but point to be noted that there was a the rapidly increasing in a number of tweets. And the data set here that to be noted is the number of people, probably around 200, 250 for lakh on in each instance of it, and then for ILA is about 2,500. And but for when you come to the Texas Edu Chat, the long-term chat space, it's about almost like 27 months of it. We are seeing that there is a lot of fluctuation among them. So when you try to analyze this from a SIR point of view, what you understand is for LAC, for example, you can take all the susceptibles and LAC, for example, for 2017. If you see that the number of people are about 500, and then for LAC 2019 about 300 plus people. But even though they had so many people in LAC 2017, the interaction, or the red, okay, just to be clear, the blue curve that here means susceptibles, the red curve here means infectives, and the green curve here means removed. So you can see that the infective curves are the infection spread is really slow, and that it can be understood from here from the alpha, which is the rate of infection at 10 power minus 10 power minus 3. Uh, and here you can see that the rate of removal is also really slow. And the R naught value, which is nothing but the possibility that an infection can happen, is actually is it's about it's order of, it's less than, R naught is less than 1, but still the infection, you can see that the infection is happening. But when you compare to 2019, you can see that the red curve spikes immediately on day 2 as opposed to almost after between day 4 and day 5 here on 2017. So here what you're trying to say is that the interaction of people has changes depending on what the content or the conferences, what would they like to discuss on an online platform. So that is something that can be influenced by the conference organizers as such to improve this into online interaction. Because and you look at ILA in 2017, they definitely had higher number of people. So it is not necessary. So you might think that having the larger group would improve the interaction online. No, because the case is by day 3 there are higher number of infectors, but you can see that the curve has dropped immediately up from day 4. So basically saying that there are certain times in the conferences that allow people to interact more or have or around the idea of the conference itself. Since we are talking about hashtags, it's about the social participation that has something to do with what's going on in the conference or the probably after the keynotes are over on the first day or some specific the topics that are there. And then Texas Edu chat, you see there's not least interaction happening. So the topics are really sparse, and the way sustaining people over 27 months of time, the same number of people is very difficult. So here what we see is short term, anything that needs anything that requires you to uh, uh, if you want the idea to sustain and move forward, you need to have a short-term goal of it, and the that's the conclusion from here. So what we propose here is the modeling of ideas and saying that idea spreads from one person to another person, and especially when you bring down to the learning or education perspective, this modeling is useful to understand how how students are learning or how online resources are helping them. For example, you want to take a chat, a discussion board session on edX, let's say, you can use this kind of framework to see how many people are connected, and then one step further, that's a next stage of research that we're going to move forward, is actually understand what is the topics that they're discussing and how it is evolving. So, and that would give the both the instructors and also the student an idea about okay where it is moving towards. And on a high level, it can also be used towards and assessing what's going on in specific. Let's say, for example, if you take 10 years or 10 years of lack and then try to analyze this, you can come up with the ideas about okay, how did let's say student engagement patterns have changed to from in class to an online, or maybe some other topic of research that has been there but actually had found its modifications, or you can say mutations, because I'm talking from epidemiology point of view, and has found its way to what it is today. So that gives a better idea for even for research. So these are the different applications that I can give as examples. And here we're basically trying to test the plausibility of play of this framework through social participation, and we see that the greater infection rates than greater recovery rates are required in order to sustain the idea, and the conferences can improve their in participation online. And future work basically would be, as I mentioned, historical patterns of the all the 9 years, and including this year would be 10 years of lag, and then trying to understand any specific field topics of interest, and also including some network models as others have done for spread of ideas, but trying to bring in that portion also and to see how exactly where the nodes are, where the larger nodes are, and then see who are the most influencing people who can, through whom we can get those ideas out. So, and that basically requires us to integrate some things like text mining and natural language processing techniques, which and also the further research questions would be who are the people who are involved, and the others, and what background do they bringing to influence the spread of ideas. And thank you. And final topic I want to say as a real life example is, for example, if you take 2019, there was Dr. Ryan Baker's challenge, and then it found its way back here and back in another place. So challenge number one found its way back here. So if you say that an idea of Dr. Baker has been posted online and then has been tweeted and retweeted enough that it stayed with people long enough, and also people know, people who have attended the conference too, that they're picking up from there and then actually working on that. So this is a real life example of transmission of an idea. And the so that's how the modeling of the lifespan of idea framework relies on. Yeah, thank you.